Hello, this is Mrs. Mackey, and you're going to be happy today because it's not a long video. It should be a much shorter video than yesterday, although getting rid of fractions and decimals are very liberating, very nice. Okay, today we're going to do equations that have variables on both sides of that equal sign. So how can we collect like terms when I have an x over on my left and an x on my right? No vocabulary review today? Yes, thank you, Mrs. Mackey. All right, here we go. Example A, looking at the problem, it looks almost like the problems we've done before. In fact, it looks like a basic two-step equation. It just isn't, though, because I have two variables here. You know, I don't like how this won't let me change its size. There we go. Okay, so moving this out over the way, I have a little bit of room to work. I'm going to draw my equal sign, my line down the equal. This is where people make mistakes on the left and right a lot. So at least in the beginning, you might want to try this if you're getting confused at everything. Okay, so I look at my problem, and I need to move all my variables to the left and all my numbers, my constants, to the right. And so I do that by adding opposites. I'm going to start with my numbers, and I have an 2x squared. Okay, so I have that 2x on that other side. So I need to do the opposite of 2x. And the opposite of a positive 2x is what? That's right, it's a negative 2x. So I'm going to add negative 2x to both sides. What I do to one, I must do to the other. Notice I am lining these up underneath their like terms. This is going to help me later. And I draw a line because it's a one big addition problem. So I look at it term by term. 5x minus 2x gives me 3x's. I've not done anything with my 2, so my plus 2 stays. Equals, now here's where it's going to go away. 2x minus 2x is 0, so that's gone. And I'm left with my 14. Okay. Now we have a basic two-step equation. I'm going to add the opposite of negative 2 and then divide. I'm going to add the opposite of 2 and then divide by 3. So here I go. Plus negative 2, plus negative 2. These cancel out. My 3x comes down, equals 12x. And so when I divide each side by 3, x equals 4. This is once you get down to a one-step equation, especially if there are no integers, no negatives involved, you can skip straight to the x equals 4, if you are good. Now, if you want to continue to write this, of course you can. You may always do less. You just can't do, you may always do more. You just can't do less. Okay, here's one for you to try. And apparently I didn't change this word, so I'm going to get rid of this. See if I can fix this. Boom. Sorry about that delay, but now you have the right ones. Okay. We're going to move the variable term to the left-hand side by adding the opposite, copy the problem, then do that first step only. Pause the video now. Okay, so divide the problem in half. We're moving the variable term that's on the right side to the left side. So hopefully you added negative 4x. Oh, sorry, k in this case. So I'm left with 7 minus 4 is 3, plus 2 equals negative 10. Now we're at a basic two-step equation. Pause the video, finish up the problem. I apologize, my answer is a little bit sloppy, but hopefully you got the same answer as I did. K equals negative 4. Let's hope I didn't make any mistakes this time. Next problem. Another example. B. This is a multiple step equation with variables on both sides. It is one of the only thing that is missing from here are fractions. So this is one of the most complicated kinds of linear equations that we have. And if you can do this, you know how to solve equations pretty much very well. Okay, so here we go. I took my steps out of the way, sorry. If we have subtraction problems, we have two different places we can change it. Because it's inside parentheses, you can change it now. Or if you'd rather, you can do it after the decimals and fractions. But this is a summary of everything we do to solve a simple, what we call linear equations. So, step 2, get rid of my grouping symbols. How do I do that? Starts with a D, distributive property. And then, if I had any decimals and fractions, I can get rid of them. Combine my like terms and on the same side, if I had any. And then I start working my isolating the variables. That's moving things and inverse operations. So that's a little shortcut. You'll see how this works a little later. Well, as we do this problem. Okay, so I'm going to start and do my keep, change, right there. And now I'm going to use my distributive property to get rid of my parentheses. 2 times 5x is 10x. 2 times negative 1 is negative 2. Now I'm going to do my other one. So this is distributive, step 1. Distrib. Okay, actually I guess you could do my subtraction problem. But 3 times x is 3x. 3 times 11 is 33. Now I'm going to do this just like I did the last problem. I'm going to move my variable to the right-hand side by adding the opposite. I guess I'm moving my right-hand variable to the left-hand side. I apologize for that. Okay. So the opposite of 3x is negative 3x. So I'm going to add negative 3x to both sides, taking care to line up my like terms. This is gone. This is just coming straight down. 10x minus 3x, or plus 3x, if you want to think of it that way, is 7x. I forgot my plus sign. There we go. Now I have a two-step equation. Solve it. Well, pause it, solve it, check your answer. Did you get it? Hope you did. Okay. Last problem. I'm going to do those same steps. This one is more with you. You're not going to have to solve it all the way. I want you to use the distributive property first, and then we'll do the second part, and then you'll do the last part. Okay, so do the distributive property and then check your answer. Is this what you got? 12b plus negative 6 equals negative 6 plus 12b? If so, excellent. Now we're going to move our left side variable, no, right side variable term to the left by adding the opposite. Pause the video, come back. Did you get something weird like this? Is negative 6 equal to negative 6? This is a special kind of equation. This kind of equation is called the identity. Oh, helps if I learn to spell. Identity. The identity equation means I could use any number in the world for b, and it's going to be true. There's also a kind of problem we'll learn about later where there's no solution, where no numbers will ever make it true. All right, here's a review of all steps to use. You can write all of these down, take a screenshot. We're going to be creating something together in class. So if you wanted to go back and write the shorthand, you may, or you can write these longer hand. You need to have the steps. I just don't care which way. We have to get rid of any grouping symbols. If I don't have grouping symbols and I have decimals and fractions, I'm going to get rid of them. Then I'm going to combine like terms on each side of the equation if I have them. I don't always have them. Then I'm going to use the properties of equality. That's when we add the opposite to both sides. And then I use properties of equality to get rid of my coefficient, and that's another inverse operation when we multiply or divide. You always should be checking your solution in the original equation, even if we don't take time to do it together in class. TTFN.